Radhe Radhe to everyone. So welcome to you all. Here we are solving CMI questions. This is question for today. Suppose f is a function whose domain is x and codomain is y. It is given that mod of x is greater than 1 and mod of y is greater than 1. Only these two conditions are given to us. Rest we don't know anything. Okay. So there are questions 16, 17, 18. So question is that for each x in x, every x in x, there exists y in y such that f equals to y. ठीक है. Then for each y in y, there exists x in x such that fx is y. The next one is there exists a unique x in x such that for each y in y, it is true that f of x equals to y. Next is there exists a unique y in y such that for each x in x it is true. Look, there can be many options, we can elaborate it, but there is a twist that we have given some options. These are the options and we have to choose out of them कि हाँ which one will be more appropriate. So our first question was that for each x in x there exists y in y. So yes, it can happen, ठीक है, because अब y is also greater than 1, ठीक है, x is also greater than 1. So yes, there can be options. So we can say that first option it can belongs to 16 question. Easily say this thing. Now next is for each y in y there exists x in x such that f of x equals to y. So for this particular thing, we have to say when it will be possible. It is always possible when your function is onto function. So this we can say कि yes, this is true, but when it is onto function, we clearly see कि yes, this happens when your function is onto. The next is there exists a unique x in x such that for each y in y it is true. अच्छा, there exists a unique function x in x, unique function x in x such that for each y in y it is true. Now look, we have used these two options, so we say कि no, this is not true. This is option is not at all true. That your unique function x in x and such that y in y and this is equals to fx equals to y. This condition is not suitable. Now next is there exists a unique y in y. Okay, there existing a unique function y in y such that for each x it is happening. So this happens only when your function is constant function. This is saying that your y is existing and for each y there exists a x as well. So this happens only when your function is continuous function. So these are some of the options that can match our questions given to us. You have to just think how what could be the other options. Now next question we have, write a sequence of 9 letters indicating the correct option to fill the number blanks 1 to 9. Do not use any space, full stop or punctuations. Example, this is in a correct format. Okay. Now as we can see that we have to choose from the options. Okay. If we are looking to the question, it means we have to find any P and C and all, but let's look into the option. What they are saying, option is that this is large, small, greater than, equal to, not equals to this. So if we'll say like your sufficiently very small h, okay, this h is greater than 0, it is given that f of a plus h is less than equals to f of a. ठीक है. Now for such quantity, how we can write f of a plus h minus f of a over h, it must be this. Okay, now we take the limits. So this says your f dash of a must be this. Okay, a parallel argument for such negative value of h gives, like if it is a negative, then it is like this. So we can clearly see that f dash of a is 0 here. So out of all option, what we easily can conclude is that a function is differentiable. Look, what our condition is that we have to see what could be the options, what and all, okay, sequences. But if we have to choose out of the option, so this is the best suited option we have. Okay, so I hope this is clear to you. Thank you so much.